Great. Thank you so much, Guillaume and Nick, for that presentation. We have a ton of questions flooding in already, but I just want to send a reminder to our audience. If you would like to submit a question, just use that Q&A box, which is located in the bottom right corner of your screen. Or if you're viewing the program in full screen mode, you can use the toolbar at the top of your screen. Just type your question and hit submit. So, like I said, we have a lot of questions coming in already, so let's jump right in. The first question, lots of drones can already do autonomous missions with drone deploy or Pix4D, for example. So what is unique about Skydio?
Yeah, absolutely. I think we talked about this a little bit when we were in the 3D scan section. But with your drone deploys and your Pix4Ds, you have two ways to capture data. You can either fly a planar grid flight, where you'll fly a lawnmower pattern up above the subject that you're trying to capture, or you can fly by hand. Now, both of those are dangerous. I was talking to a collision reconstruction specialist, a police officer, who was doing a mapping mission in a parking lot and got his DJI Phantom stuck in the golden arches of a McDonald's. And then, similarly, you get all kinds of crashes when people start flying down by hand around structures to get a closer look, because you don't always see everything. Sometimes there's a power line that there's some glare, and even the best pilots crash. And so having a drone that can come down and actually scan, we call it 3D scan because the drone is moving in 3D as it scans and captures every surface, is really, really game-changing. It means that your pilot can be a lot calmer and that you're going to get much more consistent data without having to take the thousands of pictures that pilots take now just to make sure they don't have to go back to the site later. So we're very excited to fit into that capture phase, and then be able to pass that data into the existing photogrammetry systems that people have.
Great, thank you. We had several questions come in around the topic of visibility, so I'm going to compress them and kind of try to hit them all in this one question. Things like, can Skydio operate at night or on low visibility conditions? How does it work in dark situations with respect specifically to avoidance?
Yeah, absolutely. So there's a different answer for Skydio 2 and for X2. The X2 brings night flight, but the Skydio 2 doesn't. And what I always tell people is the best way to think about what these drones can or can't do is to imagine a little pilot sitting there on the drone and looking around. And if it's dark, your pilot can't see much. And so your Skydio 2 is not going to fly at night. Your Skydio X2 will fly at night. It'll be able to use GPS and a magnetometer, but your obstacle avoidance will be disabled. And so we do see a lot of value to doing these night flights, but at night, just like any other drone up there.
All right, great, thank you. Similar kind of question, many came in around this topic as well. What about resistance to things like wind, in bad weather, rain, snow, et cetera? Can you talk a little bit about that and how it reacts in those situations?
Yeah, absolutely. Your Skydio drone is always reacting to wind and keeping you stable. They're rated for up to 25-mile-an-hour winds, and your pilots will get ample warning if the wind is getting too high for the system to be able to take that out and dampen it and keep your drone in the right place. I want to call out Justin Woodjack. Great question about the Skydio being able to handle a hall of mirrors. I can't handle navigating a hall of mirrors, and we haven't tested the Skydio there, but I'm sure it would do better than I can.
Let's hope. Okay, so next up, somebody was asking if Skydio drones can be outfitted with LiDAR systems.
Nope, unfortunately not. But we do think that we can do a lot of things with vision that are really expensive to do with LiDAR, right? So with LiDAR, you're looking at a $25,000 to $30,000 system just to put the sensor on there. And in general, our philosophy is, your hardware can get smaller, lighter, cheaper, and you can add all of that value with the autonomy software. And so LiDAR hasn't been a part of our philosophy yet. We tend to address the same problems that LiDAR does, like the software company that we are, not like the hardware companies that we compete with.
All right, great, thank you. One attendee asked about whether developers are going to be able to develop drone applications based on using your hardware, and how would that work?
Yeah, we've had some limited kind of OEM or powered by relationships. We tend to like to invest pretty heavily in them. And a couple of examples. Number one are Drone Deploy. Drone Deploy's app works with a Skydio just like any other drone does, and we're really excited about that partnership because it's opened up a lot of inspectors that use Drone Deploy to now getting to access this autonomy and do their operations with even more precision. Another one is EagleView. And so if you go to our website and look at the enterprise skills or the autonomy skills section, you'll see a product called Skydio House Scan that we deliver through EagleView, which is the leader in providing aerial data and works with a lot of roof inspectors. What we built there in partnership with them is a similar variant to 3D scan that's able to identify all the facets of a rooftop and get down to, I think, 0.2 millimeter precision on that rooftop, and works right in line with the rest of their applications, and we've trained their pilots on it as well. So there are certainly opportunities for this. I highly recommend anybody who's interested in developing with us, get in touch, fill out a form on our website, and we'll have the team in touch with you if there's a fit.
Wonderful, thank you. A few questions about, I guess, accuracy, for lack of a better word, in terms of what is the smallest opening that the Skydio can fly through, as well as what is the smallest object that the Skydio can avoid?
Sure. So those are two different questions in the way that we think about things at Skydio. The first is a question about what is the obstacle margin? How far will you stay away from obstacles? And in general, when you're having trouble getting through an opening, it's because the Skydio doesn't want you to go crash into the sides of it. And so what we've done with the Skydio Autonomy Enterprise Foundation is built-in precision mode. Precision mode lets you fly within a half a meter of an obstacle on any side of the drone. And that's good enough to get you through any standard doorway. Now, the second question is about what is the smallest obstacle that you can avoid? And the answer there is actually kind of amazing. The Skydio 2 can even the X2, right? Any Skydio drone can even avoid obstacles that it doesn't see. And that's because you've got a dozen neural networks on there that are drawing conclusions about the world around them. And if you go on our website, you can find a video where the Skydio is flying near a power line, and the cameras can pick up one section of power line that looks like it's just floating in space. Now the drone is going to draw conclusions that usually power lines don't just hover, they're connected to more power line that I also need to avoid. And so in that 3D map of the world that the Skydio is making for itself and constantly navigating through, it'll even detect obstacles that it can't see. So we get really excited about that. That's the kind of next step that gets you over that reliability threshold so that you can actually trust these collision avoidance systems in the enterprise.